dear students, I am Pragyan from Dipol School. Today we'll start the lesson Electrolysis, and this chapter we will discuss in three parts. And in the first part we will discuss introduction of electrolysis, terms related to electrolysis, and mechanism of electrolysis. Okay, then we will start now. What is actually electrolysis? The name itself tells that one. It is the combination of two words. One is electro, another one is lysis. What is the meaning of electro? Electro meaning is passing of electricity, or it is the electrons. Lysis, separation of ions. Okay, so all together it combines to give the definition of electrolysis. It is the decomposition of chemical compound, any chemical compound we are taking, in its aqueous and molten state. This word is very important, fused state or the aqueous solution, by passing of this electricity. Okay, then we will go for what are the terms related to electrolysis. So now we will discuss terms related to electrolysis. So first of all, the container which one we are taking, that is known as your electrolytic cell. So let us take this one. This is the container which must be a non-conducting. So this one is known as electrolytic cell, and it must be non-conducting. Okay, non-conductive means non-conductor of electricity. So second one, it comes related with the electrodes. We are taking this one as electrodes. Okay, and this electrode we are connecting to the terminal of the battery. Which side it is connected to the positive? Which electrode it is connected to the positive terminal of the battery? It is said to be positive, and which is negative terminal is said to be negative. Okay, so electrodes, it is of two types. One is your anode, another one is cathode. Anode, it is positive in nature, and cathode, it is negative in nature. But one thing remember, this current we are taking, this one should be a direct current. We cannot use alternating current. Never we cannot use, because 50 times in a second it changes its frequency. So the substances which are taken inside that electrolytic cell are known as electrolyte. And all the substances, do you think all the substances whatever we are taking inside that one can be considered as electrolyte? No. So the chemical substances are divided into two parts. One will be electrolyte, another one will be non-electrolyte. And in this electrolyte, the chemical compounds that conduct electricity is in the fused or in that aqueous state. We cannot take this one as the solid state. Solid state is big no. Okay, and it undergoes a chemical decomposition. In the electrolyte is that substance which undergoes chemical decomposition. And remember, in case of chemical bonding chapter, we were discussing the substance which will conduct electricity. Which type of substance? Those are electrovalent or ionic compounds. They conduct electricity. Now, non-electrolyte. The word it is non-electrolyte. Obviously, it shows that one it will not conduct electricity. And here, if no conduction of electricity, here no separation or no decomposition takes place. And all those are, if this is your electrovalent compound, this one will be your covalent compound. And here, these polar covalent compounds will be exceptional case, and it will come to the electrolyte, but we will discuss that one afterwards. Example of electrolytes are this NaCl solution, HNO3, all this. And here pure water, sugar solution, kerosene, everything will come under non-electrolyte. Then again let us divide electrolyte into two parts. One will be strong electrolyte, another one will be weak electrolyte. This strong electrolyte, they dissociate completely. The word completely means here, see, depending upon the degree of dissociation. What is degree of dissociation? Means how they are ionizing. So here it is represented by alpha. If alpha is greater than 30, then those are strong electrolyte. So here, as dissociate completely, so large amount of current flows through it. And dissociate completely means only ions only present here. Now let us see that one, what is weak electrolyte. Here degree of dissociation, this degree of dissociation will be less than 30%. So less amount of current flows through it. So see here, we are taking this one dissociate partially, the word partially. Do you think that one, all the whatever molecules are there, they will dissociate? No. This one will be partially. So, some of the ions will be present, some of the molecules will be present. So, this is the great difference between these two. One will be ions only present, another one will be these ions and molecules are present. Here, we can say that one strong acids, strong bases, copper sulfate solution, NaCl solution, all those comes under this strong electrolyte. Whereas in case of weak electrolyte, acetic acid, which are the weak acids, they come under acetic acid. Acetic acid, it can be NH4OH. This one can be also, this one it is a weak electrolyte. Okay, now take the screenshot. If we want to take the screenshot, so we will discuss that one. What are the other things? Okay, now ready? So here what we will discuss? This one sometimes board question comes. What type of particles present in a strong electrolyte and weak electrolyte? So under strong electrolyte, what we will write? Ions only. So here, and in case of weak electrolyte, we will write ions and molecules. So it sometimes it gives some example. For example, it can be elements present in particles present in CH3OOH, acetic acid solution, or acetic acid, or dilute acetic acid. In that case, you can represent ions and molecules. Okay, so this one, this is about this strong electrolyte, weak electrolyte. This part is over. Now we will go for electrodes. So it is electrodes. We have taken this one. These are the substances through which from the current comes from this direct current comes. And so it is of two types. One will be your anode, another one will be cathode. Okay, so anode, it is positively charged electrode, and this one, it is negatively charged electrode. And one important thing, current enters through that anode. So here what we can say, see this one, it is anode I have taken, this one is positive anode, so current will enter through the positive and it will be out through the cathode. Okay, this one will be at anode and cathode. So here we can say this one positive, current enters, this one it will be current leaves. Another one, it is anode, it is oxidizing electrode, and this one it is reducing electrode. Okay, this is the most important thing, this electrolytes. Electrodes. We have discussed about electrodes. Now we will go for these ions. Okay, so these ions are again divided into two types. One will be cation, another one will be anion. Why this one is anion? These ions move towards anode. Which are moved towards anode? Negative ions move towards anode. So negative ions are known as anion. Cation ions move towards cathode. That one will be, so which are it is towards cathode? So positively charged ions, they move towards cathode, and negatively charged ion, they move towards anode. Okay, so these are all about this anion cation. Now let us see that one, how it happens. For example, I am taking AB. So if I am taking AB, this sign is important. This one is reversible sign, and this one is the dissociation or decomposition symbol. So A plus, this one decomposed into A plus and B minus. So here A plus is given and B minus is given. So what happens? A plus ion move towards cathode. Okay, and B minus ion moves towards anode. Understood this one? So like this ionic reactions takes place. Okay. So here A plus ion, which is known as your cation, and here examples are metallic ions are known as cations, and here they move towards cathode, and B minus, this one it is your non-metallic ions, they move towards anode. The most important is hydrogen. It is a non-metal, but it loses electron to become H plus ion and it moves towards cathode. This one is most important for us. Now let us will go to discuss mechanism of electrolysis. Under that one we will discuss characteristics of the electrolysis. The most important is that how, if we are taking AB, it is maybe in that aqueous solution, or we can take in this one is the molten state. So in this case, let us take this one as the molten state. Here AB give rise to A plus B minus. Here it says that one, how many electrons lost? Electrons lost is equal to electron gain. Means this number of electrons gained by the anode is equal to number of electrons donated by cathode. Another example let me give you. So PbBr2, it give rise to Pb2 plus and 2 bromine minus. So here lead metal loses 2 electrons to become lead ion, whereas 2 bromine ions is formed by getting 2 electrons. So this is the most important mechanism in case of electrolysis. So now let us discuss electrolytic dissociation, and here we will go for ionization. This is most important, and remember where we had read this? We had read this in case of this chemical bonding chapter. So dissociation and ionization. We had read dissociation, it is the separation of ions. Ionization, it is the formation of ions. And this one, this electrolytic dissociation, it takes place in electrovalent or ionic compounds. But this one takes place, ionization takes place in covalent compounds. That too, it is your polar covalent compounds. Now let me take this one, let it be NaCl, let it be molten NaCl I have taken. So this dissociate, give rise to Na plus Cl minus. But in this place I can take HCl, which is in that aqueous form, give rise to H plus Cl minus. And other example also can be those metals which form ions. Let it be copper. This copper, to form this ion, it have to lose 2 electrons. So we can take this one as copper, and copper ion plus this one. This is also example of ionization. Okay. So now this is also another board question. This one here we can take, it is a distinguish or difference between this metallic conduction and electrolytic conduction. So we will take metal and we will take electrolyte. In case of metal, let us take copper wire as an example of this one, and electrolyte, let me take copper sulfate solution in case of electrolyte. Okay, so what happens in case of metal? Free electrons are responsible for conduction of electricity. But in case of electrolyte, ions are responsible for conduction of electrolysis. In case of metal, what happens? No decomposition takes place. But here decomposition takes place. How this one? What if you are taking copper? There will be no decomposition. But in case of copper sulfate, it dissociates. Let it be aqueous. We are getting copper 2 plus, sulfate 2 minus, H2O. We are getting H plus, plus OH minus, chemical decomposition took place or not? But here in this case, no decomposition takes place. Here what happens? Here we are, this one it is a physical change, and this one it is a chemical change, and this is a board question 2 years back. This one is a board question, that is the difference, and why this metals, this copper sulfate electrolyte, it cannot be consumed, is equal to the metal. So this one is the board question. You can take a screenshot if you want. Okay.